तुमको ऐसे पता है जल्दी।
डॉक्टर तुकाराम, जस्ट आपका नेम शेयर कीजिए वो चैट में, सो दैट आई कैन फाइंड आउट वेदर चैट इज गोइंग प्रॉपर और नॉट. Okay, so it's clear that chat is clear. Now today, this video is recorded for the purpose those who would not attend. It is for that purpose. In previous session, we talked about epidemiology little bit and little bit about research method. We talked about inductive research, deductive research, why research, etc. Today, we'll talk a little bit about the statistics, and then together, I would like to start with once we talk something about the statistics, we'll start with the PSBH. PSBH is nothing but a problem solving for better health. That strategy will be taking after we talk something on statistics. Now, this is such a common word, central tendency, and so many people are using this word central tendency, and the our simple meaning is if you have a population of 10,000 population and you are going to take a sample of only 100, and based on one sample, if you want to find out the population parameter, then what will happen that there will be some gap. But if you take multiple samples of that population and then you try to find out the population parameter based on a sample, more and more closer you will be able to find out. So, core means nearer to the truth you will be able to go. and that is known as central tendency. So central tendency gives an estimate of the distribution. For example, if you want to compare two cities, for example, the Ahmedabad and Delhi, and then you want to find out what is the distribution of height of the people in Ahmedabad and what is the distribution height of the people in Delhi. That kind of distribution we can find out, and it may differ from different contexts. So central, if you have a geography, there's a different meaning. If you have a statistic, it's a different meaning. If you have mathematics, a different meaning. The word center. And suppose if we are talking about mean, it will be a mathematical estimate, total and divided by number of the observation. That will get to mean. And sometimes you want to have a middle order in terms of the order. If you go, it's a median, middle values. And there sometimes it would be a what are the observation which is frequently occurring, most frequently occurring. So three things: mean, that is the total divided by number of observation; median, the middle value; and most frequently occurring. MO is the most frequently occurring. It could be this. These three measures of central tendency are frequently used in a different context. Now, this is a mean we are talking about. Look at the total, we are mathematically going about it. Then this is not required nowadays because uh, there is a computer. So you need not make a total of observation divided by number of observation because computer is going to give it. And in AP info, you will get it by means command or by frequency command. We'll see that. Now, this is something where you weighted mean, assumed mean. So, if when we are going to this assume mean, when we have a lot of figures to make a total, etc., instead of that, we can just subtract, for example, 90, 80, instead of making a total of it. If we remove 80 from all, then also we can get a mean. Now, this slides will be given to you, and you can try to find out if you are beginners. For group data also, we have the method which usually you don't require because now AP info is there. Right? In, in terms of central tendency, there are mean and mode also. Now we are going to talk about median. But in terms of variation, if you want to find out, suppose in Ahmedabad, what is the height of the people? So lowest height is, let's say, 50 centimeter, and highest, let's say, it is around 200 centimeters. So that is the range. But that range will not tell you much. Then other thing is the variance, in which you are making a square of all the differences, and that is going to give you variance. But when you take a divide by number of observation at that time, you will get a standard deviation. So that formula will be there. And visibly, you need to look at the shape, right skewed or left skewed like this. So next thing we'll be talking about median. And you need to arrange in lowest to highest range, and then you can find out the middle value. But suppose if there are even numbers, so for example, 10 observations are there, then number fifth and number six both will be the middle value. At that time, you need to find out the middle of the fifth and sixth, that you can find out average, and that will give you the middle value. And the advantage of this middle value is it is not affected by extreme value. In case of mean, what happens? So you are taking a weights. Someone, let's say, is between the range of 50 to 60, most of the people are there. But suppose one fellow is having weight 130 kg, then that will shift the mean towards upper side. And that mean may be highest from all the people in the group. So that will happen. Or one person is interested in 50 to 60 kg range, but one person having a 5 kg weight. Then when you count a mean, it will distract over the lower side. So in such cases, median will be more useful, which is a middle value. And so ideally, when you interpret the data, if you have mean, median, and mode, that will be much better. This is a exercise whereby you will be arranging the data and finding out the middle value. In this case, you have two middle values, 7.7 and 8.9. So you get a mean of that. That will give you the middle value, median. So if there is a group data, then there is a different formula to find out the middle value. Mostly it doesn't require because of the computer. Also, so other thing is mode, most frequently occurring values. Or sometimes there may be several modes, bimodal, multimodal, like this. In this figure, you can see that 4.9 is a one mode. If you look at here, there is no mode. All are equal. Here is a one mode, 4.9. In this case, more than one mode is there, 43 and 28. And mode, in case of a group, there is a technique that can also be used, but mostly nowadays is not required because of the computer things. Now, this relationship between mean, median, and mode, usually mode equal to 3 median minus 2 mean. This will be usual mode. When mode is not given, if you want to find out, then you can use this technique. Now, mean, median, and mode. They are the three things. What is a mean? Is basically balance point, or because it is a mathematically calculated. And median is a middle value, and mode is a most frequently occurring value. This is something about central tendency, but what you need to remember that central tendency, central is a different thing. Central tendency, central values, all the three things are different. So when you are talking about central tendency, you need to remember that central tendency is a different word altogether than the central value. Central values are mean, mode, median. And central tendency means whenever you have a large population and you want to find out the population parameter based on a sample variable, that the value gradually it will go towards the center. Whatever the actual value, it goes towards that. Suppose the population parameter is, let's say, hemoglobin level is 11 gram. And the sample parameter, first sample found out that it is around 9 gram, another is 9.2, is another is 12. 12.3, 12.4, something like that. When you take a larger the sample, large number of samples, when you take, and you will find that gradually it goes near to the real values. That is the word central tendency, and that's why uh, if we utilize a certain formula, we can find out a population parameter. Now, these two words are very important. When you talk same thing, weight, suppose when I talk weight of the population, it is a parameter. When I say weight in a sample, it is a variable. So, based on sample, when you talk about the population, that could be some differences because you have taken sample, it may not be the exactly. At that time, mean, mode, median, then the variation, standard variation, all these things are we are going to use it. So we need to understand mean. Now, why we do that? Because if there are 100 observations, because if there are 100 observation, all 100 if you describe with another all 100, it's so cumbersome. That's why when you want to compare to population or same population today and after 10 years, after 1 year, after 10 days, at that time you cannot compare each and every value. That's why we measure some kind of thing. So the middle value we talk. One thing, if we want to, let's say, compare two population, then we can compare the middle value. But as you know, the middle value differs a lot. Mean may be same, but then the dispersion may be of a different kind. That's why, along with the mean, if we measure the dispersion around the mean, that is more important. What is the lowest value or the highest value? But sometimes what happens that out of 100, let's say 90 people are between 50 to 60 kg. But then five people having, let's say, 1 kg, 3 kg, 4 kg, other five people 100 kg, 200, 300 kg. So mean may be the same in both the group, but the dispersion may be of a different kind. At that time, even a range is the same in both the group, but then the dispersion within the group may all be different. And that's why we need to standardize this procedure, and that's why the concept of standard deviation. Central tendency or central value alone cannot describe the characteristic of population and tells us nothing about how they are dispersed around the center. And that's why, to get a better picture, we need variation as well as central value. Look at this. In this, if you can see the observation, this and this, both are same. Here the observation are there. All the three means are same. But you can see the dispersion is different. All the three. This line you should look carefully because the next, when we are going to talk about the standard deviation, standard error, at that time, this will be very, very useful. Most of the time, when I talk to the students, what do you mean by standard error? Then they buffer. And if I ask you in the chat, for example, do you think, let me get you involved, only 2% are there. So, do you think that standard error is one type of standard deviation? Think a while and answer yes or no. Answer yes or no. Do you think that standard error is one type of standard deviation? You can write yes, no, or do not know. No. Then someone else. The person has not written the name. It's only D. What do you mean by D? Please write. Can you write your name? D matlab. Can I have your name, please? Uh, okay, good. So, actually speaking, standard error is nothing but one kind of standard deviation. And because this is a video recorded, let me spend few seconds on that. See, you have seen that these kind of observations. For timing, let's think that you have uh, 10,000 population and you want to take a sample of 100. I repeat, you have 10,000 population, you are going to have sample of 100. Now, how many such sample you can take? If you have population of 10,000, you have 10,000 population and you want to take sample having size of 100, right? How many such samples you will be able to take? Just write down the number. Sample having 100 people and your total is 10,000. How many such sample you can take? 100. Good. What Dr. Dhanya says? 100. So this is what we believe that out of 100 into 100, so is a 10,000 population. But it's not like that. When you take a sample, the word sample means subset of population. So today I take 100 individuals. Just I replace one, go back and one another. Then the subset differs. And so it's a different sample. So you can take thousands of such samples of having 100. So it's not that you can take 100 only, thousands of samples you can take. And there's a formula by which you can calculate. Right? There's something like R 10,000 and CSR, right? So what is the probability of getting from this? There's a calculation and you can get this. My purpose is you can thousands of samples you can take of 100. But now just concentrate that when you take thousands of samples out of this 10,000 population, then remember that mean of each sample, that itself becomes another population. So I repeat, means of samples, they themselves make up another population. And means of samples, mean of means of samples will be almost equivalent to the population mean. This is a very, very interesting. You can listen it second time, third time, that when you have, let's say, 10,000 population, you are taking 100 samples or more than 100,000 samples. Let's say you are taking 1,000 samples, each having 100 sample size. And when you find a mean of all the samples, that means itself have a different kind of population. And the mean of this means is almost equivalent to the population mean. Now, this means they move around. They are dispersed around the mean of the means. So for timing, let's say mean of the means, we use the word population mean because it's almost equal to. So around the population mean, the sample means are dispersed. And that dispersion of means of samples around the mean, that dispersion of means of samples around the mean, that is if you measure by standard deviation, then there will be standard deviation. So standard deviation of means of samples around mean of the means of the same population mean, that standard deviation, when you measure, that standard deviation is known as a standard error. So when I take one sample, based on that, when I talk about the population, that standard error we are finding out by a spatial measure. That will be how we are standardizing that error. That will be talking and very interesting. Yeah, I will repeat. So, let me write down something in the chat that will be much useful. See, we have 10,000 population. Okay, you have understood? And we can take thousands of samples having sample size of 100. Okay, this is also very clear. Let's say we have taken 1,000 samples, each having 100 from 10,000 population. Clear? Now, all these 100 samples will have, or 1,000 samples will have 1,000 means because each sample will have one mean. So let's say we have taken 1,000 samples and we have 1,000 means. And for time being, this 1,000 mean will also have one mean. And for time being, we call it as population mean or estimated population, but it will be almost population mean. So mean of this 1,000 mean of 1,000 means will be almost equal to population mean. Now, uh, these 1,000 means are dispersed around this population mean because there will be some, everyone will not be exact. Suppose population mean is 50 kg and other means, 1,000 means, they are something like 50.1 kg, uh, 51.2 kg, something like this. So this 1,000 variations from the mean. Now there are 1,000 observation around that mean, so we can find out standard deviation of this means, standard deviation of means around the population mean. Standard deviation means around population mean. These standard deviation, if you measure, then that itself is known as standard error. We are not actually in practice doing 1,000 samples and 1,000 mean. Without this, we arrive at standard error. There's a beautiful method because standard error, how we are finding out? What is the calculation behind that? It's very simple that if on a small sample, from a small sample, instead of 100, if you take only 10 individual, error will be more. And if you take out of 10,000, 9,000 population, error will be less. So automatically, the standard error will depend upon sample size. Better the sample, larger the sample, lesser the error. Similarly, if variation within sample, if variation within that sample is more, standard will be more. Because based on when you talk about population, it will be problematic. That's why we are finding out standard error formula. Standard error is equal to SD upon root n because it is inversely proportional to the size and that the root of that. So there is actually standard error is nothing but kind of standard deviation. This concept is important because standard error we are using for standard proportion, standard of mean, standard of difference between two mean, standard of difference between two proportion, all where so many times standard is coming. And that's why this concept is important. Now, measure of dispersion, we have a range clear, variance also clear because the mean minus observation make a square, that is the variance, and standard deviation take a root divided by, that is the standard deviation. This parameter, we'll look at the formula quickly. range is very clear, minimum and maximum. Standard deviation. This standard deviation, if you want to remember at midnight also, is basically nothing but you measure the difference between mean and the value of any observation. So, observation minus mean, that is negative or positive value. To remove that, we are making a square of it. And that's why this making a square is to remove the negative or positive sign and get an absolute value. And when you divide this square by the number of deviations, you get standard deviation. I repeat, if I use the word mean deviation, what does it mean? All the deviations from the mean divided by number of deviation. All the deviation divided by number of deviation, that will give you mean of the deviation. But this deviation may be minus or plus. So if we have two methods to remove that. One is absolute value, another is make a square of it. Now, if you take an absolute value, it doesn't give you so standard. That's why we are taking a square of it. Once you make a square of it and then divide it by number of deviations, then you get a good number of very good standard, and you are making a root of it because you have squared something. So when you take a root of all the deviation square divided by number of the deviations, you are going to get a standard deviation, which is so standard in terms of the statistics that most of the time it gives these values. And when such normal distribution chart is with you, remember that this height represents the number of observations and width also. So width into height, that area, total area will give you the approximate numbers. So this 34.13% is basically 0.34 in terms of probability. On the very first lecture, we have seen that percent is 100, but in terms of statistics, we never write 34.13. In that, we write 0.34. Here we write 0.13. Here write 0.02, like this. Right? So standard deviation now, what does it do? Plus minus 1 standard deviation, if you do it, it will cover 68% of observation around the mean. Plus minus 2 standard deviation, if you take, it takes almost 95% of the observation. There is a plus minus a little bit, but with a broad understanding. We are not going to in nitty-gritty of 95.4, something like that. So standard deviation will tell you how many people lie between these two. 2 and given by standard deviation. Mean plus minus 1 standard deviation, mean plus minus 2 standard deviation. In this case, it is a two-tailed test. In both the sides, there is increasing and decreasing. If the thing is only increasing or only decreasing, the method will change. So this is a simple what I told you, that he in a square root do the summation of all those all the deviations, make a square of it, make a total, and then divide by the n. In case of data less than 30, why we are doing minus 1? Because let's say you are having a birthday party and 10 people of you are there. So you have given one place, the birthday boy, उसके घर सब जाते हैं तो उसके नजदीक में जाएंगे. So that deviation will be almost nil. So one value will be almost near to the mean, and that difference between this variation between mean and that one value will be negligible. And that's why, because it is not negligible, it is ignored at the time of, automatically ignored at the time of making total of it. That's why to get an exact idea, we do n minus 1. And if the distance is large, 100, 200, 300, then minus 1 or not is not going to make a difference. Otherwise, ideally, you should be doing n minus 1. This is an example is given, is not required, right? Group data also, there is a technique is given over here. We did not go through that. Very simple. If you go through this and if any is a problem, then we'll be going through that. And there's something like pooled standard deviation that is also used sometimes, in which both these variations are made a total and combined it is down minus 2. So it's a one sample, other sample, both sample together. We are combining the deviations and then is a pooled standard deviation, both samples. Now, most of the time, this coefficient of variation, people are not using it. But I would request that whenever you are comparing two things, definitely try to use coefficient of variation. This is essentially because the standard deviation and the mean, this deviation, coefficient of variance, how far it is varying. Because suppose standard deviation, let me write in the chat and find out whether you can make out or not. One simple standard deviation is, let's say 5 and mean is mean equal to 50. This is one sample. Another sample as the one, the standard deviation is 10 and mean is 1000. Now, by mistake, it is SD11, but SD1. Now, SD here is a 5. And SD here, another SD1 is equal to 50, is equal to 10, is equal to 10. Now, tell me, SD is more or SD1 is more? Tell me that. SD is more or SD1 is more? Can you write down? SD is more or SD1 is more? आप जवाब दीजिए. SD is 5, SD1 is 10. Which one is more? SD is more? No. SD1 is more. SD1 is 10. So, answer is very simple. SD1 is more. Standard deviation is more. But look at the coefficient of variance. In terms of mean, if you see, then if you look at in terms of this, then you are right that S is more. That variation is more than in compared to the means. Because in terms of that, 5 divided by the if you take a 10, it will be different. And in this case, 50 divided by 1000, it will be different. So this is coefficient of variance. This 50 is much less than this 5. Right? So this is how we can find out coefficient of variance. SD upon mean multiplied by 100. That is the how far the deviation is there in terms in context to the mean. This mean in here you should concentrate on the word that epidemiology is always looking for denominator. USD to USD, if you compare, you say you're right, this is more or less. But when you compare in terms of denominator, in terms of this mean whether this SD is more or not, at that time coefficient of variance in terms of mean how much SD is there in terms of percentage, this is important when you compare the data. And usually people don't do this, but it should be done. This is another example they have given, right? That already given that example. Then the quota usually not used, but that can be easily calculated by AP info. The 25 percentile, 25 to 50, 50 to 75, 75, like that. So now the exercise are also there. This already the data is given to you. All the slides are already given in Google Drive. I have shared with you. And if you go through it, if you have any problem, then we can discuss on that. I stop sharing over here, and I would request that before we do anything today, I request you to take up one problem, pick a problem. Just today we'll be talking only of the problem and then how you will go about your study. That is, we are spending few minutes on that. So both of you are requested that in your day-to-day life, all right? I don't know what Dhanya is doing or what Dr. Tukaram is doing, but in your day-to-day life, you are finding some problem, and we want to solve that problem. We are going for that. So can you write down one problem? It's not necessary that you take that as a project, but for understanding purpose. So first, you can prepare list of problems, not now, but later on, list of problems. Maybe 8, 10, 20, 30. You can list, you can have a group of 5 people or staff, etc., and write down the problems. And then select one problem for the purpose of learning. Can you write down one problem over here for the sake of learning? Poor nutrition among children. Very good. Other problem? Then you can write down one problem. Antimicrobial is good. Now, these two problems which you have selected, in case of research, what we do that we define this and that you all of you probably know. And once you've done the refinement, let's say you have done refinement, then as on the first day I talked about why. Ask them why antimicrobial resistance. There are three, four factors. Why? So ask 5 times, make a chart of that, and down there. So what? If my antimicrobial resistance, so what? So what? You do that. Simply for the poor nutrition among the children, also you do that. And then when you collect the data, you prepare the database. And that database is now to be analyzed and select your problem. But when you prepare a format, try to make a uh, format in a such a way so that you have both the type of variables. One is a variable where you can find out a mean, and another variable where you can find out the percentage. Characteristic variable, for example, the person is having diabetes, non-diabetic, or person in malaria, no malaria, or happy, unhappy, something like that. Black and white, veg and non-veg, like this. From where you can find the percentage. And you should also include the variables from where you can find out the mean. For example, height, weight, calorie intake, or the dose of the antibiotics given, something like that. So that when you apply your AP Info software, that you learn both the techniques. And uh, so if you have question, you can ask. Otherwise, we'll go for the AP Info. I have those who have given me an email. I have shared with them AP Info 7 for installing on your computer. Once you install that folder as it is, and outside the folder, launching AppInfo, exe file, you do it. I have shared you zip file. You unzip that, and then you will be able to start using AppInfo immediately. If there's a problem, on TeamViewer will be sitting, and then I will help you how to install the AppInfo. Now let us see how to use AppInfo. Once you have prepared your problem, you have made the database for that. You have done a Google form, or you have done the data in the Excel, and then we'll see how it can be used. Info 7 will look like this. Zip file I just made today to share with you. The APC Info 7 folder will be this, and then will launch AP Info 7. The moment you launch AP Info 7, you will see the menu. Now in this menu also, this create forms, enter data, and create maps, statistic, all these things are there. Now, this probably I would like to teach you if time permits at some point of time, but it is very, if you select the temple, the templates, that is the fastest way. But if you want to learn, you should learn with the new project. And when you write the new project, it will ask you for the multiple database, and this way you can do it. This comes under the learning AP info. But there is a help also there. There's a manual also. From that you can learn. This is a basically a program generator where you can make your own program, and then you can do the data entry. Once you prepare that, enter the data in the project which you have prepared. Now, presume that this kind of data is entered, and then you want to do the analysis. And this first thing, you read the file. The most difficult part is installation of AppInfo and selecting the file, because you may not be aware that where is your file. It is under the project, under the sample, and PRG file is there. So there will be one session exclusively for learning AP info, maybe a half session or so that you can learn it and you can practice it. Once your epidemiology and statistics is clear and you want to start a research, at that time this analysis will be much easier. I'm just selecting Oswego file. There's so many other files are there for learning purpose. Now, two things you have learned. One is how to open the AP info, and second, how to read the file. Now, here we have learned the how to open the AP info file. But if you want to open up your Excel file in the next couple of sessions, I will tell you how to open the Excel file also. If you have your data, Excel data, keep it ready so that we can do the analysis with AP info. Now, I want to look at the list of this file. I can use the command list. I can see the variables and I can see the files. Also, you go file I can see like this as if you are looking in Excel. Right? Total 75 people are there, and you can see the variable at the top: age, sex, illness, etc., etc. So there's the list command. Now, from that list command, we want to find out the frequency. Suppose we want to find out frequency of all the variables which are given, then this is a star, right? If you don't select star and select the cabbage, for example, how many took cabbage not? So you will get a frequency of a cabbage only. But if you give frequency star, then you will get frequency of all the variables in the file, all the variables, you will get the frequency. age, mean, mode, median, everything you get, right? This is within few seconds you get all the frequencies. To give an example, if I take frequency of age, then I will get range 3 years to 77 years. That is the range. We also get a confidence limit for each thing, right? This is how we are getting. And if you use this command, means of age, then you get total number of zones 75, mean is 36.8, standard error is 21, variance 460, median, minimum, maximum, mode, everything you get it over here. 25%, 75th percentile, median is 50th percentile by using the means command. And if you want to have a cross separation between two exposure variable is, for example, milk versus illness. This table command you can use and it will look like this: illness versus milk. Horizontal, vertical percentage, keep a quiet, try to look at this 2 by 2 table. And in case of epidemiology, 2 by 2 table can be of for to find out sensitivity, specificity, standard proportion, or it has a multiple connotation. So this 2 by 2 table, in this case, gives standard error of difference between two proportion, which we can do manually. But here they give so many things. For us, usually, if it is the cohort study, right, then we can go for relative risk. If it is a case control study, we can go for odds ratio. That will be again talking in terms of when we talk about statistics. But then right now you are concerned with your p-value, which is zero point 0.6, and it says that there is no significant difference between milk and illness. The same thing when you go for tables between the day I talked about the vanilla versus illness. If you look at this, then this square suggests proportion, right? This is 3, so almost there is a very small square over here. This is 43, so this is a bigger size. This is 18, so this is. So these four values, 43, 11, 3, and 18, they are represented graphically by this near by the table. So again, you can definitely say this is a bigger, right? But if you look at the p-value, this is less than 0.05. If you go further, 0.0001 is less than this. So highly significant association between the vanilla and illness. So I stop here. Now the session is open. If you want to ask any question. So I hope that you will write down the any you will take any problem and do the why exercise, so what exercise, try to make a form, Google form or so, and collect some data of 8 to 10% and try to analyze in AP info so that it will be much better. So what you should be doing at around tomorrow, maybe 11 or 12 or so, you can see it on Team Viewer. Initially give me a call between 11 to 12 sometime, and then I will join by Team Viewer, and then probably I will be able to install. I will give another number also in a group. I will share so that right now, tomorrow you can take help of that person in installing AP Info. If he fails, then I will help you. And also, all should get enrolled in HSC education platform is there, and try to get enrolled in that. Access will be given to you, right? Yeah, it's very important. What topic? So let me tell you about the topic. I have already shared uh, the I have shared the session also in the Google Drive. You just need to look at the Google Drive. But for now, I will tell you what we have shared with you. Uh, it is into 7. All this is given. Session 1, session 2, session 3. It will be the session 3 on statistics. We have taken this 3, and this outbreak will be giving only few minutes, but you should be going through all these files, presentation of data, type of source data, etc., including assignment, and then we'll be going for this kappa test and LQS methods. This you should be ready next time when I do it. The reason are very simple that these are the thing kappa test and LQS method very useful. Test of significance, standard proportion, etc. So mostly what I do, test of significance I take initially, then I go for kappa test, and then if time permits for LQS method. Right? Outbreak will be giving only few minutes for that. So, and this you should be registered on HSA education platform. Hitesh by number I'll be sharing in group. You look at that and do two things. One is get registered for HHO education platform so that you can see various courses and all the slides available. Your previous slides also you will be able to see in that previous videos also. And other thing, if you have any problem, then AP info installation, it is where will help you. And the series is already written over here, one by one, that what we are going to learn in this order. Right? This this is already written in the Google Drive. This is the usual order. Right? We'll also have a non-parametric test for a small sample size. We'll be also talking about again control cost study. For screening, my one session, video session is there on screening that can also be done. Then there will be a special session on AP info practice because by that time you would have done your data collection and you are ready with your Excel file. That's why. Once you practice it, then we'll have a revision of biostat, a little bit advanced, what we will do in the terms of complicated thing. And then in the last session will be on project proposal. You should have a complete project proposal. The headings are already given, but it should be written in such a way so that funding is much easier. In which statistical test you are going to use, that also will be deciding. And if time permits, we'll be going for question answer, etc. My next session, as I understand, is during Diwali days, and I would prefer that we'll be extending later on. But the next session, instead of 21st, it will be on 28th and 30th. 28th October and 30th October, there will be next session will be there. Meanwhile, you can go through all the files and try to keep your questions ready. Okay? Any question? No? So I'm leaving, right?